Hi everyone, it's Sorkin. Today we have a problem when we are given a staircase with the n stairs, and at each step we can make either one step or two steps, and we need to find out that how many ways, unique ways are there to climb to the top of the staircase. So for example, in this case, if we have, let's say, 3 stairs, so we can go one step at a time. That's one unique way. Another one is we can go one step and then we can go 2 steps. That's another unique way. And the next one is we can go 2 steps and the plus 1, so which means that the reverse, right? So 2 steps and then 1, so that's another unique way. So there are totally 3 distinct ways to how we can go to the top of the we can climb to the top of the staircase. Let's take another example. Let's say that the n is equals to 4. How we are going to solve this problem? We are going to solve this problem using dynamic programming bottom-up approach. So what is dynamic program bottom-up approach? It's an approach where we are splitting a problem to a sub-problems, and then we are building up to our solution. So for example, let's say that our n is equals to 2, right? N is equals to 2. So for the first step, right, so how many ways there we can go to the first step. The ways that we can go to the first step is just the one step at the time, right? So it's just one step. For the second one, we can either go to the first step and to the second step. That's the 1, so 1 plus 1. And another one, we can go directly to the second step, which is 2. So there are 2 distinct ways how we can go to the second step. Let's increase one more, right? Let's say that we have 3 steps right now. If we have 3 steps to the third step, to the last step, right? How we can go to the last step? The way we can do that, we are either going from the first step, right? We are making 2 steps, or we are going from the 2 and we are making 1 step. So which means that the unique ways go to the third step is the combination of the first one and the second one. So we either go from here, or we are going from the first step, or we are going from the second step. So 3 plus 1 plus 2 gives us 3. How about the next one? Let's say that we have 4 here, right? 4. Again, for the 4, the unique ways go to the 4. The only way we can go to the 4 is either from second or from third. So which means that whatever unique ways go to the second and the third, the combination of it would give us the unique ways we can go to the fourth step, right? So the sum is equals to 5, and again we are adding one more, 5, right? It's the same for 5. To go to 5, either we can go from 3 or we can go from 4, which means that the 3 plus 5 gives us 8, and so on. So it's like a Fibonacci sequence, right? So the next element is the sum of the 2 previous. So what we do here is, as a solution, we are creating. So first, if the size is less than 2 or equals to 2, we are just returning whatever the n is, right? For n, for the 1, we are returning 1. For 2, we are returning 2. If it's not, then we are creating array dp with the size of our n, and the way at the first step, we are setting the dp1, we are setting to 1. We're setting actually n plus 1 because we are going to use not the 0 index, but we are going to start from the first index. So we are dp1 is equals to 1, dp2 is equals to 2, and starting from 3, or whatever the n is, what we do is we are taking the sum of the 2 previous. And we are, so for example, for 3, it would be the 1 plus 2. For 4, it would be 2 plus 3, and so on. At the end, we are returning dpn. Actually, we don't even need the dp here. Dp meaning that we can just meaning that we don't have to even create additional. We don't have to create additional array here, so we can just take the 2 previous one and store it, and for the next one we are going to take the sum of the 2 previous and update the 2 previous, and at the end return that result. But for the sake of simplicity, we are using an array dp here. So what's the time and space complexity of this solution? This solution, exactly, the time complexity is n, because we are going over our array at least once, and the space complexity is of 1, of n also, because we are creating an array with the size of our input. But again, we can avoid that, and we can make the space complexity here is constant, but for the sake of simplicity, let's say that we are using dp. And that's it. That's it for today. I also have identical solution in Java. I will include that in the description. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.